Hello everyone and welcome to FRQ3 2025. Now the official solutions are not out yet. These are my own solutions. So if you feel I'm wrong, I could be wrong. So you can correct me in the comment section below and I'll do it as soon as possible. FRQ3. Now, in FRQ3, I feel that we have a lot of content from which only some part of it is actually useful, or maybe most of it is useful. So I recommend that while going through FRQ3, don't be in a hurry. Okay, read each and every line and then try to think what that line is trying to imply. So we'll start. For a guitar to make a sound, the strings need to vibrate or move up and down or back and forth in a motion that can be modeled by a periodic function. Okay, that tells us nothing. At time t is equal to 0 seconds, point X on one vibrating guitar string starts at its highest position, 2 millimeters above its resting position. Okay, which means that this entire line would be y equal to 2. And then it passes through its resting point, which means it comes at 0 and moves to its lowest position, 2 millimeters below the resting position. 2 millimeters below the resting position would be y is equal to negative 2. Point X then passes through its resting position and returns to 2 millimeters above the resting position. This motion occurs 200 times in 1 second, which means the period is 1 over 200. What happened to my pen? Yeah, 1 over 200. And the increment would just be 1 upon 4 times 200, which is 1 over 800. Now, once we have this and this, it is quite simple for us. So I'll start with the y values. So f is 2, g is 0, j is negative 2, k is 0, and p is 2. Now f is t equal to 0. Don't put 1 over 800. We have the initial position at t equal to 0. Then we have 1 over 800. Then we have 2 over 800. I'm sorry for my bad handwriting. Then we have 3 over 800. And finally, we have 4 over 800. These are the coordinates. You could simplify them. For example, 2 over 800 is 1 over 400 and 4 over 800 is 1 over 200. If you want to, you can do that, but no problem. So that was part A. Okay, part B. The function h can be written in the form h of t is equal to a sine b t plus c plus d. Find values of constants a, b, c, and d. Wait, why is it sine? I actually hate this question because this is a cosine graph and now they're gonna force us to get it into a sine graph. Yeah, I hate this FRQ. So anyways, moving ahead, irrespective of whether it's a sine graph or a cosine graph, we will have a few things. Same, for example, the midline over here has to be 0, right? So D has to be 0 whether it's a sine or cosine graph. Our period, okay, our period is given by b over 200, b over 2 pi. So which means 1 over 200, which is our period, is b over 2 pi, which means our period b will be equal to 400 pi. Oh my god, that is mind blowing. Okay, so our period is 400 pi. Okay, we solved two values already. Now amplitude. The amplitude will be 2, but it could be negative 2 as well if I take a negative sine graph. But I always like to start from the beginning. So a sine starts from the middle. So instead of taking point G, I'll take this point as my starting point. So I'll have the amplitude to be 2. But in that case, my my C point, which is my horizontal shift, will have to be negative 3 because, yeah, this is negative 3 over 800, right? So which means that my C will now have to be equal to negative 3 over 800. And yeah, I think that should solve it. This took me a lot of time because I was a bit confused between amplitude and the horizontal shift and stuff. But yeah, here's an answer. Or another answer that they will accept is if you have B and D as the same, but if you have A as, let's say, negative 2, in that case, you'll have C to be negative 1 over 800. they will accept both of these answers. Okay, let's move on to the last part. Part C. Refer to the graph of H in part A. I already have that here. The t coordinate of G is T1 and the t coordinate of J is T2 on the interval T1, T2. Which of the following is true about H? So what is H? H is between G and J, which is this part that I'm highlighting right here. I hope it's quite clear over here. Yeah. And which of the following is true about H? Well, we can clearly see that it's between 0 and -2. So it has to be negative. I'll cross out these answers. And we can clearly see that it's decreasing. So I'll cross out this answer, which means our correct answer is D. H is negative and decreasing. Now, whenever we have H is negative or anything to be negative, it will be concave up. It will be concave up. And don't get too happy because I also ask about whether the rate of change of H is increasing or decreasing. And since it's concave up, the rate of change of H is, I'll write rate of change is increasing. Okay, I guess we're done here with the FRQ3. It looks a bit tough to me, but it has a very compact and small solution. Nonetheless, here it is. Let me know if I'm wrong anywhere, and have a good day. Thank you.